Friends, welcome to the class. Friends, already we discussed about what is probability and the terms associated with probability like trial, events, experiment, etc. We also saw three types of problems in our previous class. In this class, we'll discuss some more types of problem in probability and we'll also go through some questions. So let's start. Type 4. Problem based on selection of an object from a box or a container. In this type of problem, we have to find the probability of selecting an item or object of a particular type or pattern or color from a container or bag or box containing such objects. Let's see some examples. Cards are marked with numbers 5 to 50. One number on one card are kept in a box in random order. One card is drawn at random from the box. Find the probability that the number on the card taken out is first bit a prime number, second bit a number which is a perfect square. The total number of cards are marked is 5 to 50. That means the total number of cards in the box is 46 because 1 to 4, the numbers card with number 1 to 4 is not there. The starting number is 55 and it ends at 50. And also it is given that the cards are in random order. That means it is not in a sequence manner. So here the total number of outcomes is 46. Now come to the bit 1. Let E1 is the event of drawing a prime number. So how many prime numbers are there in between 5 to 50? The number of outcomes favorable to E1 is 13 because there are 13 numbers of prime number lies between 5 to 50 and the prime numbers are 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43 and 47. So we can say the favorable outcome is 13. So the probability of drawing a card with prime number or PE1 is number of outcomes favorable to the given event, the total number of outcomes, or it is equals to 13 by 46. Now come to the second bit. Let E2 is the event of drawing a number which is a perfect square. So the number of outcomes favorable to the E2 is 5 because there are only 5 numbers 9, 16, 25, 36 and 49 which are the perfect square. So the probability of drawing a card with a number which is a perfect square or PE2 is 5 by 46 is the answer. Three bags containing 10 oranges, 10 apples and 10 mangoes respectively are mixed together in a large bag. If one fruit is taken out at random, find the probability that the fruit is first bit an orange, second bit an apple and third bit not an apple. So the large bag contains 10 oranges, 10 apples and 10 mangoes. That means total 30 number of fruits. So the total number of outcome is 30. Now first bit, that E1 is the event of selecting an orange. Now how many oranges are there in the large bag? 10. The number of outcomes favorable to E1 is 10 as the total number of oranges in the large bag is 10. So the probability of selecting an orange or PE1 equals to 10 by 30 which is equals to 1 by 3 is the answer. Let's come to second bit. Like E2 is the event of selecting an apple. Now again in the large bag there are 10 number of apples. So probability of getting an apple or PE2 equals to 10 by 30 which is equals to 1 by 3. Now let's come to the third bit. Let E3 is the event of selecting a fruit which is not an apple. So the number of fruits, number of outcomes favorable to E3 or the fruit which is not an apple, that means fruit which is not an apple means they are either orange or mango, that is 20. So in this case the probability of selecting a fruit which is not an apple or PE3 is 20 by 30 which is equals to 2 by 3 is the answer. Or alternately we can do it, probability of selecting a fruit which is not an apple and a fruit which is an apple are complementary events, and we know the sum of the complementary events is always 1. So you can write Probability of selecting a fruit which is not an apple equals to 1 minus probability of selecting an apple. This implies P of E3 equals to 1 minus P of E2, or it is 1 minus 1 by 3, which is nothing but 2 by 3. That's it. Type 5, problem based on geometry. In this type of problem, a geometrical figure is given. We have to find the probability that the given object lies inside the geometrical figure. To get the probability, we have to find the area or volume of the given geometrical figure, or part of it, of the given geometrical figure, or both, a part of the geometrical figure and the total geometrical figure separately. Let's see an example. A helicopter is reported to have crashed somewhere in a rectangular region of length 8 km and breadth 6 km. A lake with sides 2 km each is situated inside the rectangular region. Find the probability that the helicopter crashed inside the lake. So, given that the dimension of the rectangular region is 8 km to 6 km and that of the lake is 2 km to 2 km. So, the helicopter is equally likely to crash anywhere in the rectangular region. Now, area of the rectangular region is 8 into 6, which is 48 km square, and area of the lake is 2 into 2, which is equals to 4 km square. Now, provided that the helicopter crashed inside the lake is nothing but area of the lake by total area of the region, or it is nothing but 4 by 48, or we can write it as 1 by 12 is the answer. Type 6, miscellaneous problems. To solve such kind of problems, we have to find the total number of possible outcomes and the number of outcomes favorable to the given event. And probability of the given event is nothing but number of outcomes favorable to the given event by total number of outcomes. Let's see some examples. Savita and Hamida are friends. What is the probability that both will have the first bit same date of birth, second bit different date of birth, ignoring the leap year? There are 365 days in a year, so Savita's birthday can be any one day, any day of 365 days. Similarly, Hamida's birthday can also be any day of the 365 days. So here, the total number of outcomes is 365 into 365. Now, onto the first bit. If both Savita and Hamida have the same birthday, in that the number of favorable outcomes for their birthday is 365. That means the record probability or probability that Savita and Hamida have the same birthday is 365 whole divided by 365 into 365, or it is nothing but 1 by 365. On to the second bit. Probability that Savita and Hamida will have different birthdays. It is nothing but it is a complementary event with the first bit. So we can write probability of Savita and Hamida have different birthday equals to 1 minus probability Savita and Hamida have the same birthday. That is nothing but 1 minus 1 by 365, which is equal to 364 by 365 is the answer. Find the probability that the number selected at random from the numbers 3, 4, 4, 4, 5, 5, 6, 6, 6, 7 will be their mean. So the given numbers are 3, 4, 4, 5, 5, 6, 6, 6, 7. That means total numbers are 10. So the number of possible outcomes is 10. Now let's find the mean. How to get the mean? Mean is nothing but sum of the given numbers by total numbers, or it is 50 by 10, which is equals to 5. But how many times 5 is appearing? The given numbers 5 is appearing 2 times. So the number of favorable outcome is 2. Therefore, the record probability is 2 by 10, or it is 1 by 5 is the answer. Find the probability that a non-leap year selected at random will contain 53 Tuesdays. In a non-leap year, the total number of days is 365. or 365 can be written as 52 into 7 plus 1. That means in a non-leap year there are 52 weeks and 1 day. 52 weeks means in a non-leap year there are 52 Tuesdays. And the remaining 1 day may be any one of the days of the week. That means the remaining 1 day can be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. So the total number of outcomes for this 1 day is 7. But only in one case we'll get Tuesday. So the number of favorable outcomes to the given event is 1. Therefore, the record probability or probability that non-leap year contains 53 Tuesdays is 1 by 7 is the answer. Probability of getting a rotten egg from a lot of 400 eggs is 0.035. Find the number of rotten eggs in the lot. So here probability is given, total number of outcomes is given. We have to find out the outcomes favorable to the given event. Given that the total number of eggs is 400 and the probability of getting a rotten egg is number of rotten eggs by total number of eggs. So putting the values, we get 0.035 equals to number of rotten eggs by 400, or number of rotten eggs is 400 into 0.035, which is equals to 14. Thus, the number of rotten eggs in the lot is 14, is the answer. Friends, here is a few questions. Practice more and more such questions, and in case you come across any difficult question, feel free to share your question with me. It will be a pleasure for me if I can help you out in solving your doubts, in solving your question. So this was for today's class. Thank you.